Welcome to Innovation and Leadership. I'm Jess Larson. This is part 2 of our interview with folks from the Stanford Computational Imaging Lab.
Well, I think the best part about academic research and just being in higher education in general is that the more you learn, the more you realize that you really don't know anything about everything. And so I think not taking yourself too seriously and just seeing what's out there, and that there are other people that are just so much better at their thing than you can ever possibly be, is really humbling.
So Gordon and Nitish, we talked a lot about different subjects and specifically the work you're doing right now in the first part. As you look at the space in general, where you guys are so close to it, can you talk about some of the other folks who you're excited to follow? I mean, Nitish, I understand you spend a little time at Magic Leap, and there's constantly folks coming out with new things. When you look at the other research that's happening or the other companies that are coming out with things, who are the folks that each of you consider leaders in the space?
There's a lot of exciting things going on right there. I mean, you have to realize that, this type of technology, VR, AR, has been around for a couple of decades. And I get really excited by looking at the pioneers who basically built the first couple of prototypes in this space. And, they're not all that different from the consumer products we know today. I think Oculus has done a big splash, of course, in 2012 with their Kickstarter campaign and everything that followed then. But, people like Ivan Sutherland, Henry Fuchs, and a lot of researchers have been working on this for, decades. 40 years. We were just at the SIGGRAPH conference this summer, and they had a reception with some of the VR pioneers. And that included Ivan Sutherland, who built the first head-mounted display at MIT back in 1968, I believe.
Yeah, this was the 50th anniversary, which is
exactly. Yeah. So, 50 years ago, these guys put exactly the same components together. It was big, it was bulky, it was heavy, it was suspended from mechanical linkages from the ceiling, but it had the same components. It was a see-through AR display where you could see the real world, and you had computer-generated images being overlaid on that. They were using very small CRT monitors that were, somehow coupled to optically to this optical path. They had mechanical tracking and ultrasonic tracking also. They already had computer graphics, which didn't really exist at the time, right? Now we go to the movie theaters, we see all these visual effects that are generated by a computer. Back then, we didn't have these algorithms and the math to actually generate images with the computer, but they implemented it already. And at the end of the day, I admire folks like that the most because, coming up with an idea like that and being persistent with your vision and following through and actually putting that together without anybody else doing it or without anybody else, even seeing that same vision, I think that's really incredible. But of course, we've made a ton of progress by now. And Microsoft has done an incredible job with the HoloLens. And that's just a beautiful piece of engineering that includes so many different aspects, including the chip design, the sensing system, the tracking, the optics, all of that. It's an incredibly difficult job. And similarly, the folks at Magic Leap, at Google, at Oculus and Facebook, Intel had a couple of projects, and also all the little startups that have been starting out, right? These are usually, a handful of people who are really trying to be creative and developing next generation technology without as much funding as the big companies and maybe without quite as many people. So I think there are a lot of different aspects to this, and all of them deserve recognition and respect. And of course, the academic groups too, right?
Yeah. Sure. How about yourself, Nitish? Who are a couple of the ones that you are probably interested in following the most, or most have the most admiration for?
Sure. I think Gordon covered a list of most of them, but I think what's most surprising is honestly that a lot of these companies I think are still in stealth mode. Presumably Apple might be working on something to this effect too, because they have ARKit for their iPhones, and they usually start out with nothing publicly known about their products, and then all of a sudden they're like, oh wait, we've been working on this for years, and now we have this polished product. So there's them. The Amazon startup that I mentioned, literally hadn't heard about them until this morning, and so I think it's really interesting how there's a lot of people working on this space that we don't even know, and it's not just the big names like Gordon said. It's all those startups that are motivated to work on this new space and bring it forward. And so I think those people are also doing a pretty good job.
And what's really exciting about this field in general is that it's such an interdisciplinary field. So we have people working on the optics and photonics. We have people working on lasers. We have people who are vision scientists. We have people working on chip design, on computer vision algorithms, on cameras, on computer graphics. All of this has to come together to deliver a user experience that is like none that we know today. And that's what makes it so exciting, because there's so many different aspects that all need to be engineered to the highest quality. And so you could name people in all these different areas that have done really incredible work, but somehow it all has to come together to make the final product.
Yeah, I'd actually be interested in talking about that. The name of the show here, Innovation in Leadership. When we talk about innovation, so often people will want to bring up, where did the idea come from, or a lot of the creativity elements. And something that maybe isn't always as sexy is, how do you get a team to cooperate? How do you interact with people who, especially with something as interdisciplinary as this, principles for getting people who see the world differently to actually agree enough to get something done. I'd be interested. Why don't we go Gordon first and then Nitish? Gordon, what are some of the principles, or what are some of the things that you feel like you've learned, both from your time at MIT and now this stuff at Stanford, of leading teams or being part of teams that are innovating?
Yeah, that's an excellent question, and it's a difficult answer. I think it depends on the type of team that you have. So if you work in a bigger company, you usually have a larger team of engineers that have very diverse backgrounds: mechanical engineering, optics, electrical engineering, computer science, vision science, and so on. And in that context, it's really important for people to be able to talk to each other. Everybody's going to speak a different language almost, and it's too easy to get sucked into your own little silo. But being really good at your specific area while not forgetting about the bigger picture and being able to talk to other people, I think that's the key. And having somebody who has that vision to lead the entire team, I think that's where the team comes together. At a university, the teams are usually a lot smaller. We have maybe 2 or 3 graduate students working on this topic. So we don't really have the luxury of being able to put a team together that has a diverse set of backgrounds. We kind of have to do everything at once. And I think that's the same in a startup to some extent, where, you have a certain background, but at the end of the day, you're going to have to figure out everything. And that's the most challenging part. So realizing as an individual member of the team that you can't rely on somebody else to do something, that you may have to figure it out. And that just means that you're going to have to do that extra mile and, understanding that language of a different community and going out there and really figuring out getting to the bottom of the technical challenges in other fields. I think that's the key to innovating at this interdisciplinary level.
Yeah. It's interesting how inconvenient it is sometimes to not be able to just focus on our own stuff, right? Or it can feel inconvenient to have to learn the other ones, but really that's where the magic happens, is being able to get the pieces to work together.
Well,
Nitish, go ahead.
I see it as a benefit, actually. So I'm driven by challenges. And so if somebody gives me a challenge, I love taking on that challenge, and just figuring out different and new things makes my job exciting. And I think a lot of our students, including Nitish, are driven by the same curiosity of understanding the world in all its different aspects. And so we're really driven by that, and we're motivated by that. The more challenges there are, the more exciting an area is. But I understand that, it is very, very challenging, and being able to work in a team is absolutely necessary.
Yeah.
Mm-hmm. Yeah. So
Nitish, what would you have to say about this? Well, you go first, and then I'll ask my question.
Sure. Yeah. So when I think my view on the whole structure of a team for innovation and whatnot is basically, I think it comes down to the people that you have. It before what they know necessarily. I think just having the fundamentals and the motivation to go out and say, okay, I know the basics of this, and I know I might need to go figure out something else about this, and having basically also or how do I say this? I guess kind of the confidence to say, I know this stuff very well, but I need to go out and learn some other stuff to make what I want to make work. And having other people around you that are also like that to play off of ideas, and also to help you build your knowledge, because maybe they know a little bit more. So I think it comes down a lot to the interactions of different people on the team, and just having really strong fundamentals and everything.
Yeah. Let's do this. Let's take a quick break from our sponsor, and then I've got a follow-up question to that. Okay, so before the sponsor break, I told you I had a follow-up question, and it's this. We our consulting firm Mylan, we've got clients from special ops and tech and nonprofit and all sorts of different spaces, and the types of conflict and the types of friction within teams, they look a little different everywhere, and they've got some similarities because it's just people everywhere. I'd be interested for either of you to weigh in on this idea of, when you think about especially driven people, ambitious people, folks with advanced degrees, and maybe who have had a lot of things in the world point to them that they're special, like in investment banking, you get guys who are rich and they feel like they're special because the world treats them like they're special. And sometimes that can turn into real problems when somebody gets a kind of a big ego. Do you have any thoughts about how people can maintain their humility even when the world's telling them they're special?
Well, I mean, I think the best part about academic research and just being in higher education in general is that the more you learn, the more you realize that you really don't know anything about everything. And so I think not taking yourself too seriously and just seeing what's out there, and that there are other people that are just so much better at their thing than you can ever possibly be, is really humbling. And I think that helps a lot with that, just, knowing what you don't know and knowing your limits in that respect, but also knowing that you can, push those limits to make new things, to make better things.
Yeah, this is great. I mean, I would say the exact same thing. I mean, you have to know your limits and acknowledge them. And I think that's the first step to overcoming them and actually learning it. I remember when Nitish joined the lab, actually, his background was mostly on medical imaging, ultrasound, and signal processing. And I said, well, we need somebody who's an optometrist here. So you have to become our optometrist in residence. And so basically I sent him off into a room, and he read 100 papers about the topic and came back, and he knew everything about it, because I knew I didn't know as much about it as I needed to. And I didn't have the time to really dig into this. And Nitish just came back, and he knew everything about vision that there was to know, at least from a high-level perspective of an engineer. That only made us realize that there's so much more depth to that, of course, that we will never figure out. But I think we have a pretty good high-level understanding now. And, just being humble about this and not building up an ego, I think that's the most important thing. The ego can really get into the way of everything, right? Like, I think this idea of not taking yourself too serious, I think that's the key, right? If you're really driven by, the innovation, the technology, the vision of it, then the goal should be to, make something that's really cool, that gets you really excited, and that will get other people excited too. If you're just there to tell everybody else how awesome you are, I mean, that usually doesn't work out very well.
Sure. Well, as we kind of wind down on the second half of the episode, the last couple of questions I have, I think, would be, both of you, academically have been a part of very competitive programs. Now you're one of the top schools in the world, working with the folks at Facebook and everybody in consumer electronics that you were talking about. For people on the outside who don't get to see what happens behind the scenes, are there any aspects of innovation and inventing the future that you feel like would be valuable for other people to understand, who maybe they're in awe a little bit, or it just feels like a black box how you guys do it? Are there any principles that you would say for other folks who want to go out and invent the future, this is something that by doing this year after year you've discovered has helped you do it better?
Well, I don't know. I think that's a tough one. When you look at actually just the two of us, we're very different in how we approach our work. Gordon actually often comes up with these crazy ideas and just lays them all out, and you don't know if they're going to work half the time. Whereas I usually come at it from the other perspective, where I'm looking at it and I'm like, well, I don't think this idea is going to work. And so there's this constant push and pull of, we should do this that might not work, versus, well, maybe we should spend our time on something that we know will work. And so having these different people and these different personalities, I think, feeds into the whole, I guess, balance of how the innovation cycle goes out. But you need a bit of both, right? You need to be able to say, here's a new idea, maybe we should go test it, or, fail fast because this idea is not going to work and we shouldn't waste our time on it.
Yeah. I mean, if you're not in this academic circle also, and in these academic programs where we do get a lot of the structured, what does it mean to be at a university? It means that we have a lot of courses, we have textbooks, that tell us all the basics about technology, about math, about the world. But at the end of the day, that doesn't really spark the innovation. It's really your creativity. But when you have an idea, I think it's really important to try to figure out the details and go to the bottom of, different aspects of it. So just having an idea that's very high level is usually not enough. You really have to understand something if you want to innovate in that space, to really understand what's out there already, what's the actual problem that you're solving, and whatever your idea could really contribute to that. So diving really deep into whatever it is you're thinking about, I think that's the key. Like staying at a very high level is usually insufficient, and it's sometimes difficult to do that on your own. So just having people to bounce your ideas off of, I think that's the key, as Nitish said, because everybody's good at something else, and just hearing a different perspective of your own idea or giving feedback on their ideas, I think that usually helps for an idea to converge and to grow from a tiny little seedling to a big tree, because every idea started somewhere small, and just nurturing and growing it right in the right way in a healthy environment, I think that's the key.
Yeah. Well, Gordon Nitish says that you're the one who has all these crazy ideas. What does your creativity process look like? Is it more time alone? Is it more time going to conferences and bouncing into other people's ideas, or what is your creativity process like?
Oh, that's a great question. I think I get the best ideas in the most boring moments when I sit on the plane and I have nowhere to go. I'm just strapped into the seat, for example, or when I'm at a conference and maybe not all talks are as exciting as you think, and you just go get a coffee, and but somebody tried to do something, but that they didn't do it right. So sometimes you're like, okay, I can definitely do better than that, and then you can start from there. Or I don't know, just going out there and getting out of your normal comfort zone. I think this is where I get the best ideas. Like if I just stay in my regular patterns of going to work, going to the supermarket, going home, I mean, that's usually an environment where I'm not being very creative. But when I go outside my comfort zone and just push myself a little bit, I think this is where, you see, maybe look at the same problems that you deal with on a day-to-day basis from a slightly different perspective also. And that sometimes helps to, find a different idea or a better approach.
Yeah, I love it. Nitish, what about yourself?
Oh, well, I mean, for me, it honestly really helps to have another person there that's slightly less down in the details, because I find myself often getting lost in the details when I'm looking at a new idea, instead of necessarily zooming back to the big picture. And so I really think for me it helps to have another person there that kind of complements my detail orientedness, and to basically just say, okay, well, this is fine, but let's push to the next thing. And so it's always this like drill down into the details and then just come back up to the big picture and say, okay, well, have we covered this big picture thing that we tried to do? If not, let's look at a different thing and drill down to the details there. So I think that's what my process looks a little bit more like.
I love it. Well, if you guys think about this idea of, let's say your technology accomplishes what you set out to do and eventually gets miniaturized enough that it's in a pair of glasses, and now there's a school kid who can read better because of it. How many years out? I mean, obviously you don't have a crystal ball, but what would be your hope when you're thinking about it somewhat optimistically, somewhat realistically? How long till you think that could be?
I think this could happen in the next 5 to 10 years for sure. I mean, we've seen a couple of pieces of the technology that are almost ready, but they have to be a little bit more developed, and then they have to be integrated into a system that really works well. And I think, from an academic perspective, we come up with ideas, we come up with prototypes, and we can do that in a year or so. And that works well. But to actually build a product, it usually takes a lot longer. Something that works, while you're going to ski, when you're in the desert, the temperature changes, like the thing falls down and it still has to work when you put it back on. Like solving all of these engineering challenges is actually really hard and making it work in reality. So, you always think that, okay, the idea's here, in 2 years we're going to see the product, but realistically, it's probably going to take a few years.
Yeah, I think it's especially frustrating working in the VR and AR space, because VR and AR have been 5 years away for the last 50 years, basically. And so I'm always hesitant to give out like projections for how long it'll be before we see this type of technology. But I think we're closer to it now than we are than we ever have been, because yes, like we've like talked to some companies that are working on this sort of idea. And I think one of the bigger concerns really is that people have to want to wear these things. And so we in the research world don't necessarily care that it doesn't look that great or that it's a bit heavier than it should be. But, when these companies go out and actually have to make it, it's like, yeah, look, we as researchers have come up with all this technology. It already works. What's the problem? And the problem is that people don't necessarily want to wear things that don't look good or are too heavy. And so I think that's part of the disconnect between, we say, oh, yeah, this technology is 5 years out, and all of a sudden it takes 20 years to make it,
Sure. Well, this has been fun. So besides visiting computationalimaging.org, where else is a good place for people to either connect with either of you or follow the progress of the lab?
I mean, I think generally you can email either of us. I think both of our emails are on that website.
Yeah, we try to put the latest news and projects on our computationalimaging.org website.
Mm-hmm.
So that's a great starting point. And
Yep.
just contacting us. Or if you have crazy ideas, or if you're interested in joining the lab in some capacity, I mean, feel free to just ping us. And, that's how all introductions were made at some stage for all the people that work with us.
Love it. Well, thanks again for making time for this.
Mm-hmm.
Fantastic. Thanks for having us.
Yeah, thank you.
Well, that's it for the episode. One other thing I wanted to tell you about, if you remember the guys from Convoy in episodes back, Ken Free and Trent Mano, I went on one of their CEO trips to New York, and I met a guy named Brent Thompson, very successful entrepreneur. He was former CEO of Jive Communications, big company now, I think $300 or $400 million. Anyways, he started a new company called blipbillboards.com. I'm super stoked they're a sponsor now. But I remember a year and some ago when I met him, I thought it was genius. Instead of having to buy 6 months or a year's worth of billboard for thousands of dollars, you can buy 8 seconds at a time for like 10 or 20 cents. You pick what billboard you want it on, what time of day you want it to run. And it just puts so much power in the hands of marketers and CEOs who want to try something and see if it works. You can buy as many or as few as you want, change it as many times as you want. I think now our podcast is being advertised on billboards in like 18 different states because we have these guys as sponsors. We're pretty excited about it. Hope you check out blipbillboards.com. Thanks.